Welcome to this course. My name is Tapas Mishra, and I am the director of your MSc International Banking and Finance Studies. Some of you might have seen me undertaking quantitative research in finance, the compulsory course. So I am teaching that one. So you might have seen me there. And I'm very happy that we have about 85 students enrolled in this class. So I am the module director, so I'll be teaching you about 24 hours of this course. And all the available information about this module is all here. If you go to this blackboard, then you can see announcements. Whenever I want to make any announcement, it should be here. And then my course content, everything should be about the module information, overview, lecture notes, basic statistics and additional materials, revision materials, etc. Everything should be here. Staff information, my details, email, phone number, home page, whatever you like, it's all here. And I will post assignment here, not now. But before I begin this course, I would like to give you an introduction of what this course looks like. Let me tell you that last year, when I taught this course, nobody paid in this course. This is a good news. And the average mark, which was obtained by student, was about 68%. Okay? And there were exceptionally brilliant students who obtained marks something around 85, 90%. And so it's a good course. You will enjoy that one. And I am supposing that all of you have at least some basic knowledge in statistics and economics. I will test that. Of course, before I begin my lectures today, I would like to know from you how much you know about some basic or very fundamental concepts in statistics and econometrics, because this course requires that you must have some knowledge of statistics, some knowledge of econometrics, because it is advanced time series modeling and it requires prior knowledge with regard to that. So I will post assignments and everything here. So books, required readings, everything should be posted in this website. And let me show you something that module information and course content. Here, just to help you gain some additional knowledge on econometrics or for this reading, I have posted a number of lecture notes which will not be covered here, but you must read them in your leisure time. Having said that, what I mean is that before you come to the next class, so you should have read all of them. For instance, I have some notes on prelude to main lecture. Random variables, its expectations, calculations and variations, formula sheet. Then additional notes on hypothesis testing. So all those things are basically governed by your knowledge in quantitative research in finance or some basic econometric statistics. I am supposing that you must have forgotten all those basic things. It's quite natural. Even if you ask me, if I remember all the formula or statistical descriptions, I must have forgotten. It's quite natural. Okay, so nothing to worry about that. So please go through those things before you come to the next class, because this class I will try to give introduction to this to the advanced time series modeling. I will discuss some basic concepts, but the teaching will require your full knowledge about all those things. So please read those things. Okay? Module information. So I have posted this in the Blackboard, so you can see what the module looks like, your exam or assessment pattern, everything is there. So let me tell you that this your assessment will be basically 50% coursework and 50% written exam. It's quite good because most of the time 50% coursework means if you get say 80%, 90% in coursework, and if you don't do so well in the written exam, so it will make up for that one. Okay, so this transition is very good, and probably because of that reason in the past, in my experience, students have gained more than 70%, 80% on the average, okay, except a few students, but nobody failed in this course, okay. And so everything, all the descriptions are here. Your different types of aims, learning objectives, everything. So, but I will try to explain a couple of points in my slides here. What is this course about? This course is all about time. This is time series econometrics. Okay, and we will try to understand the dynamics of time within this course. Actually, the fact is that wherever you like or not, you can never ever escape time. Time is very, very important element. Do you know when time began? We never know. What is the origin of time? Nobody knows it. When time will stop, that we also know. We won't know. Until for example, the universe at some point of time it will collapse, or maybe it will disappear in the black hole. You might have read about on the Stephen Hawking, A Brief History of Time, the famous physicist. So he is more concerned about the time. But I am not into the physics concept. We are econometricians, statisticians, we are from finance. I would like to describe everything about time series, about time in finance and economics. Okay? So this is a very small introduction of what time series would look like. So a proper understanding of the intricacies of time is very essential and its properties. Through time, you can begin to discover actually hidden patterns which has remained obscure from our knowledge. So we try to statistically or mathematically, I will try to describe what does time mean and how do we model it in econometrics of finance stuff, all those stuff. And objective, once you have successfully completed this course, you will be able to demonstrate your understanding and knowledge of econometric modeling, forecasting of financial time series, and competence in using the econometric software package. You know some software where you can calculate scatter, EVUs, R, MATLAB, whatever. You must have done some kind of SPSS, SAS, SAS. Some of you might have thought about this. But you will, once you have completed this course, you will be able to know some of them. Intellectual skills. So you will be able to analyze financial data, evaluate their model field, and assess, of course, out of sample properties. Then there is, of course, subject-specific skill. So once you have completed this course, you will be able to interpret statistical data and relate forecast to strategic, economic, and financial decision making, then critically evaluate statistical models and forecasting. So these are the specific objectives of this course. Okay. And outline of this course, I will start with very simple stuff on classical time series analysis. In this case, I will try to describe about determine trend, cyclicality, and seasonality. Then there I will describe something called ARMA, means auto-regressive moving average. All those new concepts, this is very new, don't worry, don't panic anything about, I will explain everything. So ARMA, then lectures 7 to 10, unit root and structural break, co-integration, all those things, all the outlines are there in your things. So over time, I will post each and every lecture note. There are some additional problems, solution, then all those things which will help you in getting a proper. Then at the end I will try to do some revision of this course. Some reading list. Basic reading list, you have Walter Enders, Applied Econometric Time Series, 2013 or even the 2014 second or third edition, whatever you get. So that will help you. Then Chris Brooks, Introductory Econometrics for Finance, which they has a lot of worked out examples, like little bit of theoretical description, then some statistical software, data analysis. It will help you understanding good knowledge of, say, for example, some application oriented stuff. Then Asterio and Hall, Applied Econometrics, and then a bit of advanced stuff. The last one, commerce term, quantitative financial economics. So some of them, at least you pick up one of the books, especially Enders or Chris books or Asterio and Hall, it will be sufficient for you. On top of that, I will keep on posting additional lecture materials plus relevant readings. If I want you to read some journal articles, I will post it here in the Blackboard. Okay, so you don't have to worry about it. Assessment, as I said, empirical project 50%, written exam 50%. Say, let's say in 2 weeks from now, after I have taken about 2 weeks, then I will post the empirical project, your coursework, in the Blackboard, and it will be a group assignment. So we have 90 students, a group of maximum 4 students of your choice. You can choose your friends, and if there is some conflict of interest, I can form a random group for you. Okay? So it's a group assignment. Then there will be, of course, 4 maximum. Too many. 5 are too many. Okay. It's very difficult to assess the contribution of each student. So 4, the maximum in the past.
5, please.
Okay, so we have an election here. 4, 5, 4, 5. So 4.5. Is it okay? How can you divide? Okay, we'll decide about that. Whatever is convenient to you, if it is 5, 5, that's not a problem. Okay, we can do that. If 5 is okay for you, but then you need to show your exact contribution. But we'll decide on that. We have some time for that. All right. By the way, can you tell me something? Do you find anything funny with my name? Tapas. You know what is that? Yeah. Let me tell you something. You don't know. Let me tell you something. When I was a student like you, I did my doctorate studies, PhD in econometrics, in time series econometrics, from Belgium, Catholic University of Leuven in Belgium. It's French-speaking country. Then I had about 28, 29 Spanish friends. And I came directly from India. I had no knowledge about French, Spanish, all these languages I didn't know. So my friends, whenever they used to hear my name, Tapas, all of them used to laugh. Then I didn't understand why they are laughing all the time. I found out that outside my university campus, there were a lot of restaurants, tapas bar, tapas restaurant. But I thought within such a short time, how I could become so famous here. Then I asked my friends, can you please explain why you laugh whenever you hear my name? They said that tapas in Spanish means a kind of snack you eat all the time, right? But in India, tapas means something different. That's not relevant. But what is most important is a food in Spanish. So it's very funny. Anyway, so the first part of your course is on trends and seasonality. Before I come back to this lecture, let me ask you a couple of questions. Let me ask, how do I describe? Okay, the starting point of any econometric or statistical analysis is to describe a variable. Say I have a variable x. Have you heard the name random variable? So you have done in econometrics or statistics X and Y, a variable, what we call? Variable X, variable Y, then you have done some sort of relation. You must have heard about those, right? But I would like to know something called a random variable. Yes, you have heard about that. What is a random variable? I am not here to lecture you on that, but I just would like to know what you really understand about that. From the term random means you draw without any prefixed probability. It's random. Let's say that I want to randomly select some students from a group of say 90 students here to speak on behalf of me in some elections or somewhere randomly. I pick you, pick her, pick him, like that. Random, no pattern. Okay. So a random variable, what is a variable? That varies over time or across individuals, okay, across situations. That's variable, varies. Since this is a time series econometrics course you are taking, so I am assuming that this variable X, it varies over time. So I have a variable XP, variable Y, two variables. Let me focus on only just one variable at the moment, XT. So how do I write a time series? I can write the time series of a variable X. Something, anything that falls in between minus infinity to plus infinity. By the way, we have never ever seen infinity. We never know when time began. We will never know when time will finish. So that's why in practice we translate this component to this description: xt time equal to 0, which ends in t. T can be extremely large. 5, 6, 7, if it is years, 10 years, 15 years, 20 years, 100, 10th century, 100th century, like that, thousands, time, any large number. But not like infinity, not like that. Okay? So in general, in practice, in any economic or financial system, we only observe time from a specific point of time. Let me say xt is our stock price. Say stock price. And as a financial economist, you are interested in studying the dynamics of stock price for UK from say 1980 till 2060. So my t equal to 0 in this case means the beginning, the base period, from 80 till 0. So, but the general description of a time series is just like this, minus infinity to plus infinity. But in reality, we don't observe those things. We never observe those things. So this automatically translates to t equal to 0 to t. So we can always write xt like colon t as an element of 0. This is how we describe time for any variable. Okay? Now, so this is our description of a random variable over time. Now the next question. I'm sure you know mean, variance, median. These concepts you should know. Huh? skewness, kurtosis. Have you heard of those things before? Well, let me tell you something. Even if you think when I'm lecturing or teaching, if you don't know some concepts, don't get panic. Don't be okay. That's because it is normal not to know. But keep on asking me questions. Just consider me not like your teacher, but your friend. Because between friends, you can be free. Just ask me any question at any point of time. Okay? Feel free to ask. Not asking is bad. If you have some doubt, you are sitting here and go back home with some doubts in your mind. That's the kind you are carrying a baggage. But if you are here, if you think that the question I have in my mind is something very stupid, it does not make sense, ask me that question. Ask me a stupid question, because only by asking you will know. Okay? I'm just like your friend. Ask me any question at any point of time. You will be surprised that when I was in India, I was in my high school, I failed in mathematics. I don't hesitate to tell you I failed in mathematics. I got only 28. But it was a printing mistake. That's a different story. But I was so nervous. I thought I never ever in my life I will study mathematics. But my parents encouraged me, no, that was a printing mistake, this, that. But then I studied mathematics and statistics so hard. But then nobody broke my record in my marks during my universities, in Europe and anywhere. Always I always enjoyed mathematics. That is because sometimes when you fail, don't be afraid of failing. Failing is okay. It's quite normal. But you are all intelligent people. You see, you have all smiles in your face. That means you are enjoying this one. So whenever you have any question, just ask me. Just don't stop yourself. Okay? And when you don't know some concept, this is quite normal. You can go back home, study them, come back. If you have some questions, ask me. Okay? So mean, variance, median, skewness, kurtosis, and the final, a concept called normal distribution. You know what it is? Why I am asking you these questions? Because whenever I take the main lectures, they will require your some knowledge about those concepts. So, what is a normal distribution? Then you don't need to give me any statistical definition. At least just tell me what you understand. What is a normal distribution? Why do we need a distribution after all? Do you know what is the distribution? Okay. Can I request one of you randomly? Can I request you to come? No, you don't need to explain anything. I want you to come and see the distribution of your friends. Can you come? Is it possible you would like to come here? No, you don't need to answer any question. I'm not asking any question. Come here. Okay. Please have a look at the distribution, what I call distribution, of your friends in the class. Do you think there are some of your friends who are sitting, many of your friends are sitting, many of them are on the right, or many of them are on the left, or they are almost equally distributed? What do you think? Yes. What I just want to mean, a number of your friends on the right side of this, if this is the, for example, division, many of them are here, or many of them here, or many of them are just like that, normally distributed. What do you think? Just look and tell me.
So, the mean is
No, I am not asking you about the mean. All of your friends are distributed like this, or they are distributed like this, or they are distributed like this. What do you think? I think given the seating arrangement of the students, all of his things are distributed like equal.
All students are in exact.
Exactly, that's right. Thank you very much. Well, very simple. Now, let me explain something. What is a distribution? In statistics and econometrics, the importance of distribution is very, very, very much. You know, about 300 to 400 years ago, when there was no concept of econometrics, econometrics is a concept which was invented in 1940s, 50s, like that. Before to that, what we had only statistical methods. But about 3 centuries ago, when people used to work for some medicines or some immunization, some vaccines, they used to discover in France, early 17th century, 16th century France. At that time, they wanted to know, if I want to know the pattern or the behavior of a group of people in the world, how can I describe them? Let me give you a small example. Did you have breakfast in the morning today? No. You did. My friend, you? No. Me too. I'm in your category. But see, if I describe the distribution of eating breakfast, let me describe this way. So, okay? Some of us, including me, we are here. Okay? That means we skipped breakfast. Maybe we are too busy, we got up late in the morning, and some of you might be very tensed. What is Tapas going to teach us in time series econometrics? So you missed your breakfast, and some of us, we eat a lot because we eat breakfast like a king. We have that concept. And most of us, we just pick up a slice of toast or a banana, just like that. Quick, 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 quick. We are all busy, so we are eating. So that is the distribution of eating breakfast. Again, sleeping. You sleep. Let's talk about the distribution of sleep. How many hours do you sleep? 6 hours, 7 hours? On the average, 7 hours, okay. So let me say 7 hours. But then, there are some people who like to sleep a lot. Of course, exception being the fact that students never ever get a lot of time to sleep. You are always loaded with coursework, assignments, this lecture, that lecture. You have absolutely no time. So if I take the distribution of sleeping habit among students, it will never ever be oversleeping, no. But if I take the distribution of sleeping pattern of population of a region in Southampton, so you can see on the average, people sleep about 7 hours, and some older generations people, they don't have any work, they sleep about 8 to 9 hours. And then there are some people like me. I have, for the past 15 years, I have not slept more than 4 hours a day. It might seem unbelievable, but it's true. Why? Because I am in a profession which requires a lot of work. You know, I am not in a corporate job. After you have passed, you might join a corporate job. So 9 to 5 jobs, you come back home, do not think about anything else. But in a teaching or research job, teaching covers only 20% of my working time. Then 80% of the time, I must do research. And doing research means you have to do all top publications, top econometric theoretical work, which will help the university to get funding from the government. You know how the government gives funding to the university? It is because of top research publications, research engagement. So 80% of the time we have to do research. Having said that, if I have managed to publish in a top journal, it is just like a ratchet effect, you know. Once you have done one, so you keep on thinking, let me do the another, and the another, like that. So although the research, once we start writing a paper or doing some work, it takes about 1 year to finish one work. So you keep on working day and night, day and night. So I sleep until about, say for example, after 2 a.m. in the morning. I sleep, 6 a.m. I have to get up, not because of anything else, but because I need to take my daughter to school, to drop her. Okay, so that is another story. But that is one of the reasons I have not 4, but maximum 5 hours on Saturdays or Sundays. So if I take the sleeping, distribution of sleep, so some people sleep less, then sleep more, and some average sleeping. So having said that, when I am trying to do a distribution like this, I am trying to describe the pattern of a population behavior. And this type of pattern we will always use in statistics and econometrics all the time. Okay? So sometimes you might have heard about, you have done some regression analysis. Let me, this is also my second question to you. If I have a variable y, yt equal to, I just write alpha plus beta xt plus epsilon. Have you come across this type of equations? And what is this? Error. Good, very good. So what is the distribution of the error term? Distribution of the error term. So you write epsilon t is distributed as normal, then d with mean 0 and variance sigma square. Isn't it? So what is I? N for normal. This I is called identical. This I is for independent. And D for distribution. Isn't it? So we have error term which is normally, identically and independently distributed with mean 0, variance sigma square. You might have heard about this type of thing when you did linear regression analysis in some courses. But the point is that most of the time we disregard the information content in this variable. You might have just seen, oh, error term ET equal to distributed as IID 0 sigma square, without realizing what exactly it means. What does it solve? If I do not have this type of distribution, assume that our error term is not distributed as normal, not distributed as identical and independent. What will happen? Okay. Error term. Do you think in this case your error term is independently distributed? No, because current error term depends on past error term. Current uncertainty depends on past uncertainty. Today's mistakes depends upon past mistakes. It's all about dependence, not independence. Okay? So in this case, when I assume that it is independent, so in this case, when I say it is independent, here, independence means epsilon t of today is independent of epsilon t of yesterday, is independent of epsilon t at some long time in the future. So having said that, let's say that 10 years ago, the mistakes that you did, it does not affect the mistakes that you did at 9 years ago. It's independent of mistakes that you did at 8. Likewise at 1. So they are all independent. That means whatever you did in the past does not affect you. That is what we mean independence. Is it clear, or I need to explain more? So whenever we talk about independence of errata, it means this. Your past has no relevance to your current things. So that means, let me explain this way. If you see me on the road, so today, for example, for some reason, I scolded you. I scolded you, look, you guys, you did not understand the basics, these I scolded you. And one of you caught me on the road, gave me a tight slap. So you actually scolded me in the class, you gave me a tight slap. Then in the next class I come back, then I give some very tough questions, or in the exam I fail you. So do you think this is independent? No, this is not independence. Independence would mean even if you give me a tight slap or break my arm, I still forgive you. I don't remember anything from you. This is independence. Okay? So try to remember something. Whenever we understand statistics or econometrics, do not understand them just only in equation or in notational form. All these things have been designed to describe real life events, to characterize them. Everything. Mathematics is just a language. It's a comprehensive language. Can I show you how does it explain? Remember this. See how I can capture these things. Normally I give examples in many different lectures. Assume that human, many of you have seen this one, but I'm still repeating it. Human is a function of rationality. You agree or not? Okay? All human beings. We are the function of rationality. So depending upon how much rational we are, so it's a good human being, bad human being, etc., etc. Also, not philosophically, but in finance and economics, one of the most important assumptions that agents must be rational. That is the most important. Rationality, bounded rationality, irrational expectations, rational expectation, all these theories that you might have heard about or learned in finance and economics, it's based on this one. How much rational you are. Now, let me put this one in a mathematical form. So let me say this is h, it's function of r. Okay? R, h. Now, let me put this way. Limit. Some of you might have done some limit, differentiation, those things you might have done. Limit, say rationality tends to 0. Then function of r means this one. This tends to be animal. What do you think? Am I correct or not? When our rationality is 0, we are all animals. And if I just put limit, our rationality is infinity. And so function of r, it tends to be God. Only God has infinite rationality. Am I not correct? only God has infinite rationality. And we all human beings, we are somewhere in between. Okay, so all the ancient sages, Lord Christ, on all these Buddhist ones, they might be tending towards infinity, rationality. And we all human beings, so we are somewhere, we don't have zero rationality for sure, but somewhere in between. See, it's a simple concept, but I could translate it in mathematical form. I used the mathematical tool of limit theory. And this is what we call convergence. Convergence. So, limit convergence. I used only these two mathematical terms to explain something distinguished between God and animal with this one. Using this example, what I wanted to say that do not be afraid of mathematics. Some of you, it is a very natural tendency among all of us to hate mathematics. It involves a lot of equations, these, that, but don't be afraid. Just try to understand or interpret mathematical or statistical formula in terms of some language. Then only you will be understand why this error term, in this case, what does IID mean? If I break this independence assumption, what does that mean? If I break this identical assumption, what does that mean? So, before I take break and come back to the main lecture, let me, 1 second, focus on. So, in this case, as you saw, y equal to this. If I do not put any structure on the error term, forget about it. Assume that, do you agree, in real life, when you do any regression, if I write an equation something like this, is it correct expression? My friend, tell me. I have a variable y, variable x. Okay. And I describe the relationship between x and y in this form. I do not. Let me disregard this for the moment. Do you think this is correct expression? Yes? No. Because if I want to explain y, so x explains y. So there must be some uncertain term. So this is what we call deterministic term, right? Deterministic. And this part is stochastic. Stochastics means uncertain. Everything in the world, any observed economic, financial, social, philosophical, political phenomena in the real world, they always have two components. A deterministic component means fixed, which you can observe, and a stochastic component, which do not observe. Let us say in this class, while I am teaching, somehow I am not expecting the tube lights to fall on my head. I am not expecting this. But it might be happening. I cannot disregard this possibility. So, say for example, I am teaching my teaching here. Speed of teaching. Say speed. Okay? Speed of teaching. This is what? And this depends upon concentration. Concentration of students. When I see your smiling face, so I am assuming that you are probably understanding a bit of that. But I cannot disregard this alpha, stochastic factors. The light goes up, something happens here, the tube light falls on my head, my speed breaks. So this is stochastic. Whatever you do in the real world, we can never ever disregard this component. Now, the question is, if you cannot disregard the component, so this is stochastic, uncertainty term, okay? So we have to have. So error term means error. In other words, this is the uncertainty, okay? Uncertainty. So we cannot disregard this. So if you cannot disregard this term, then we must put some structure on its behavior. Having said that, what do you mean? If we cannot disregard epsilon, then we must put a structure to the behavior of epsilon. Only then, only when we have put some structure on another term like IID, etc., then only we can say alpha hat in this case and beta hat are blue, means best linear unbiased estimate. Yes, you might have heard about that. So you can say, in this case my intercept, in this case my beta, means the coefficient that explains y, the relationship between y and x, the beta, alpha hat, beta hat, they are blue, best linear unbiased estimator, only if I have put some structure there. So see, we must give a structure to uncertainty. If you do not have any control over the future uncertainty, your life is in a doom. Okay? So, for instance, in the next 1 hour, what I am going to talk to you in my lecture, I have some control over it. I know what I am going to do. I am going to teach. And you might, but you don't have any expectation from, you don't know what Tapas is going to teach. So, to some extent, you do not have much control over the uncertainty, but I do have. So, because as long as we are human beings, we must put some structure to the uncertainty. Then only you will be able to obtain this as here. Best means minimum variance. Best estimator. Best in the case. Best implies minimum variance. This is linear. L represents linear. U represents unbiased. By the way, what is unbiasedness? You have learnt about those things, right? Yes. What is unbiasedness? Not in statistical language, just tell me in your own language, what do you mean by unbiasedness?
The estimate is equal to the expectation.
Exactly. You are very true, my friend. But what is the meaning of this? But what is the meaning of this? I very much appreciate you remember that. Very good. So what is the meaning of this?
Your estimate is consistent with
Okay. You have heard about the population and sample, these two terms? Population behavior is unknown. We have no knowledge about the population. But to describe population behavior, we draw samples. And if the sample mean or sample variance or sample parameters are exactly equal to the population parameters, then we can say they're unbiased. So unbiasedness means, what is said, your friend said, expectation or the mean. Okay? So beta hat means from the sample is equal to beta. So this is from population. And this is from sample. Sample estimates, population estimates. We have no knowledge about that. Only when expectation of beta hat equal to beta, we say it's unbiased. So this is a best linear unbiased estimator. So in the last 40 minutes, let me summarize what I told you. we started with the introduction of the time series econometrics course. Then I tried to explain to you different basic concepts like normal distribution and concepts related to this blue, okay?